All right, this is Mr. Wyrick. I'm going to go over this quadratic cheat sheet. So how do you factor when a is equal to 1? Remember, this is talking about ax squared plus bx plus c. So if the a value is 1, it's something like x squared plus 3x plus 2. You're looking for something that will multiply to make the last value, which is c, and it will add together to make the middle value, which is b. Okay, so when we demonstrate on these, what multiplies together to make 18 and adds together to make 9. I can make a little factor tree, but I know this one offhand. 6 times 3 is going to make 18, and 6 plus 3 makes 9. So this factors into x plus 6 and x plus 3. They're both positive. It's going to work that way. On this one, this is x squared minus 4x minus 21. So what's going to multiply to make a negative 21, add together to make a negative 4? That's going to be, again, I know this one offhand, they're 4 apart. This is going to be x minus 7 and x plus 3. So x minus 7, x plus 3. So that's it for just factoring those. How do you factor when a is not equal to 1? It's either the MAD method or it's the box method. I can kind of show you both with this. Well, not really. I'll stick with the MAD. More people tend to do the MAD. If you want to do boxes, you can stop by. So we demonstrate with the following. First, we multiply the first and last numbers. So 6 times 15, that's 60 plus 30, that's 90. And what's going to multiply to make 90 and add together to make 19? It's going to be 9 and 10. So this is going to be x plus 9 and x plus 10. I just write them like they're regular factors. But then I'm going to divide by this number out front. Put this over 6 and over 6. This is perfect because if these went in equally, I would just write it down. Like if this was 12 divided by 6, it'd be x plus 2. I'd be done. It doesn't go evenly into either one of these, but I can reduce the fraction, which I want to do. 6 over 10 is going to be 5 over 3. So that's going to be 3x plus 5. Remember, if I can't divide it in evenly, I'm going to move it up to the front, but after I reduce that fraction. On this one, 9 over 6, those are both divisible by 3, so it's going to be 3 and 2, so that's 2x plus 3. You can check your answer real quick and make sure they multiply back together to get it. 2x times 3x, 6, 5 times 3, 15, and 5 times 2 is 10, 3 times 3 is 9. That's my 10 and 9, that makes my 19. On this one, this is something you do have to watch for. This one has a GCF of 2. So I would normally multiply it across, but this is just going to be 2 times x squared minus 3x minus 10. So this is going to be 2 times x minus 7. And, oh no, sorry, multiplying to make 10, add together to make negative 3. It's going to be x minus 5, sorry, and x plus 2. That works better for that. Okay, so that's factored. Then how do you solve each of these previous problems from the factors? All you have to do is set the factor equal to 0. So if this equals 0, if x plus 3 is 0, it's negative 3. If x plus 6 is 0, it's negative 6. If x plus 3 is equal to 0, it's negative 3. If x minus 7 is 0, it's 7. On this down here, if 2x plus 3 is equal to 0, that's going to be a negative 3 over 2. If 3x plus 5 is equal to 0, that's going to be a negative 5 over 3. Again, I can set them equal to 0, go ahead and pull it out to the side and solve it, but I don't need to. I just kind of know those. On this one, equal to 0, so that's a negative 2 and a positive 5. The quadratic formula, you'll need it, negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, the 2a doesn't just divide over here, it divides everything. So this one, there's nothing that multiplies to 5 and adds to 8. I need to use the quadratic formula. It's negative 8 plus or minus the square root of 8 squared, I'm going to go ahead and write it, 64, minus 4 times 1 times 5, which is going to be 20, all over 2. That's going to be a negative 8 plus or minus the square root of 44 over 2. So I reduce that square root of 44. That's going to split into 4 and 11. Square root of 4 is 2. So that's negative 8 plus or minus 2 square root of 11 over 2. 2 divides into these. So that's negative 4 plus or minus the square root of 11. That's where I stop. That's my two answers. Negative 4 plus the square root of 11, negative 4 minus the square root of 11. On this one, there is no b value. Remember, it's ax squared plus bx plus c. The b is missing. So that's 0 plus or minus the square root of 0 squared minus 4 times 3 times 32. Now, I had someone kind of work this one for me. It's over 2 times 3. That's a negative, what is it, 3? Oh, 4 times 3 is 12 times 32. Somebody real quick, calculator. 12 times, here we go. Ask and you shall receive. Calculate 12 times 32. That's 384. So this is 0 plus or minus the square root of a negative 384 all over 6. The negative 384, remember, it's square root of negative 1, square root of 384. This is going to be the largest perfect square will go into it is 64, and I have 6 after that. The square root of 64 is 8, and the square root of negative 1 is I. So this is going to be plus or minus, because I don't need the 0 anymore, 8I square root of 6 all over 6. All I can do is reduce this part of it. I leave the I and the square root of 6 alone, so that's plus or minus 4/3 I square root of 6. So 4I square root of 6 all over 3. I leave it there. Remember, if it's negative, it's going to be your imaginary numbers. You have any other questions? Come by tutorials. We'll see you in the morning. Good luck on the test.